Hey guys, ScannerDanner here with my son Caleb behind the camera. We're at Latour's Auto today. We're working on a 2017 Dodge Ram 2500. It has a diesel engine and it's in for an anti-lock brake system problem. I'm having some issues with my Verus. I just had an update and I'm having communication issues, and I'm halfway through a 1.5 gig file and it's taking forever. So I'm not going to be able to scan it with this. We have some other scan tools with us, and one of the things that I've been trying to do for a while is show you guys this one right here, this Top-Don Scan Pro. It's a little Bluetooth guy. I think it's like $100. And this wasn't meant to be a Top-Don video. This is a ABS issue, and I'm pissed about my Verus right now. But I do have this connected. Check this out. So the app I'm using is Top Scan, and I've already scanned this. I was shocked that this little Bluetooth scan tool allows me access to all of these modules. Like, are you kidding me? Like, that's insane. PCM, ABS, BCM, radio, driver's door, passenger door module, heated seats, drivetrain control module, integrated center stack, radio frequency hub, all kinds of other modules on here. I don't know if it's every module on this truck, but that's pretty impressive. We're here for an ABS fault. Let's see what fault we have in memory. Right front speed sensor circuit, current out of range. Okay. We're going to talk about that right front hub here. That's what we're here for. Pretty sweet that I can read ABS faults. Really, it looks like all the modules on the system on this. I need more time with this tool. This is not a tool review, but that's pretty sick that I can do that. Showing 4 faults in the PCM. So we have reductant level low, power input signal intermittent. So I'm not worried about any of these. We're not here for this. We're here for the ABS issue. The ABS issue is this right front speed sensor circuit, current out of range. Let's see what kind of data it gives us. Live data. Wow, that was fast too. Can I configure this data? So I selected edit. Sorry about the beeping at me here. I just want to see my speed sensors. Awesome. Confirm. Yeah, let's go. ABS wheel speed data from my phone with a little Bluetooth scan tool. That's impressive. All right, let's go to the right front and talk about it. So history of this had a bearing failure. This bearing is new. The bearing assembly contains the ABS wiring. It's all part of the hub. This cable would be new that runs, this blue cable that runs up to here. When the wheel bearing failed, it broke the caliper bracket. The wheel was like just about hanging off, stretched everything. Of course, all of that is new. And then I believe it was fine for a week for this customer before it started setting right front wheel speed sensor faults again. Our suspicions are a bad new part. We're gonna see if we can confirm that. Some basic tests we're gonna do once my Verus is done doing its update. We're gonna do some voltage and resistance measurements up here at the connector. But what we can do in the meantime is maybe I'm not sure if I can, but I'll try to rotate the wheel and see if I can get a reading on my phone. I can't turn, not a chance. There's not a chance I'm gonna be able to turn that. Not fast enough to be able to read anything. Okay, I did get some on the left front. Okay, right front is that one. I got no signal on that right front. And then what, can I graph this stuff? Ooh, I can graph it. There's left front, let's graph that one too. Nada. Awesome. Left rear. Immediate reaction. Okay. Tim, can you turn that wheel for me? Nice. Wait, that's left rear. Where's my right rear? There we go. It's spinning both rears. We're 81% done with our update on the Verus. I'm pretty happy with this so far, this Top Scan some of you guys have been following along. We got the top-down Phoenix Lite, we got the Lite 2, we got the Max. Of course, the company's sending us this. We use their equipment because I like it. And they sent me, in the last package, they sent me a couple of these Bluetooth scan tools. And I had heard from some of you guys, some of my viewers, how capable these are. And I was shocked when somebody told me, oh, it'll interrogate modules and do functional testing, and it's not just OBD in the engine computer. I was like, what? Are you sure? Yeah, it's pretty sweet. Let's see, can we do any active tests? Oh yeah, look at that. No way, that's crazy. I'm just looking at inlet valves and outlet valves, traction control outlet valve, the pump itself. Let's go to the engine computer, see what it gives me in the engine computer as far as active tests go. Oh, sweet. Let's turn something on so you guys can hear it. All right, let's go to the BCM, see what kind of active tests it gives us. Here, we'll do the left front turn lamp. That'd be this guy right here. That's well, I mean, I'm shocked. I'm shocked at what they're letting us do with the little Bluetooth scan tool. Is this a top-down commercial, or are we going to fix this truck? This is a top-down commercial now. As far as the scan tool stuff goes, we're kind of done. There's no signal on the right front. We're going to do some manual checks over at that connector on the other side. I can leave this connected though, in case we could do a bypass test and trigger the right front wheel to see the mile per hour on the scan tool. Maybe we'll do that. I was going to say I'll unplug this now, but I don't want to fart around with the Varus. We'll use the Varus for the tests, but I won't use the Varus to interrogate the module itself, given that we have this ability here with the data. And we can edit the data too, which is nice. Configure the list. I love this. There's our speed sensors. We'll pull those back up. Confirm. Sweet, man. My guess is the year of this is a magneto-resistive sensor, so it's going to be a digital signal. I'm going to have battery voltage on one of the two wires. That's a guess. Let's see what we got. I'm just going to back probe this. And I don't trust my ground just yet. I was thinking of bringing the power probe too, so I had a good jumper to right to the battery. I just don't know if I trust that yet. I got nothing on that wire. Okay, there's my battery voltage. So the way that these work from memory, you'll have a small square wave on the battery feed wire to this when you spin the wheel. So what we should be doing, we should be on the passenger side first, because we know that side works, and then we'll come back over here and confirm that. So let's go over there. Okay, a little bit tougher to see that connector, but we should from memory. I have a nice video on the operation of this I did with one of my classes at the school. But you have a 12 volt feed, which is your signal, and then this other wire is a ground. And you can see we have a little higher voltage on this ground circuit than we did on the other side. What that suggests to me is an open in the sensor itself. See, we have 0.5 on that. Let's rotate this. I don't think the signal is on the ground on this. On some of these magneto sensors, the signal is on the low ref wire, and on others it's on the high end. Okay, I was wrong. Signal is on the low portion of this, not on the feed. There's your little square wave signal, right? If you wanted to, we can change our voltage scales to see that a little bit better. So that's 1 volt right there, and then depending on where the magnets are in the hub itself will dictate what your resting voltage will be. So 0.5 there, and then 1.1 there. There's your signal, Caleb. This is your scan tool. That's what the computer interprets the signal into a wave. So this is live, right? Live signal on off frequency. The computer's going to take that frequency and then it calculates the internal, mile per hour based off of how many square waves it sees. And so how does it know when a wheel locks up? When a wheel locks up, that signal stops and then it starts pulsing the brakes to get it spinning again.
So it's counting the square waves?
It's counting the little square waves for mile per hour, yes. And those square waves are being generated by magnets that are in the hub itself.
Is the width of the pulses changing?
Well, with speed, if I can spin it faster, I can, right? There's your frequency change, right? And if I change my time base, we can see either more or less of that, right? If I go down to like 20 milliseconds, that's the same signal, but that's just lab scope stuff there. But that 2-second screen was perfect for what we were looking at. But there's our signal. So remember those numbers. We didn't see anything on that other wire. Right, 0.54 at the low and 1.1 at the high. And then let's go back to the feed. Let's go back to the feed wire for this sensor. I got to change my scales back. We'll go back to 20. And then just spinning it here to see, yeah, steady signal on that. Sometimes on these, what you have to do is you have to AC couple this, which blocks all the DC. I have lectures on this. Not going to cover it too much right now. But then with it AC coupled, we might be able to see that some activity on that. This is what you would do with the ones that have the signal on the feed wire. You'd AC couple, and you can see some activity there, but that's just from current flow. So on this one, the signal is not on the positive. It is on the, I don't want to call it negative. There's a 12-volt feed for this sensor, and then there's a signal. If we want to call it the low ref, I'm not sure that that's accurate. Low ref is usually a term that's dictated for a sensor ground, and this is not a sensor ground. This is a signal. Square wave. A signal return. You're getting familiar with terminology, which is good. Caleb's been working on our lecture edits. The signal return would be another name for a sensor ground. Low reference is another name for a sensor ground. Yeah, and so I wouldn't call it that because this is a signal. I got a 12-volt feed and I have a signal. Is how I would call this. Okay. Last thing on the known good side, just to see and prove. I mean, this is enough info for me right now to tell Pete to put a hub in this. But we can do one more check, which is down to the sensor. And I don't know if you can actually accurately measure the resistance of these because of the design of the sensor, but we can try. So let's do that. We'll unplug this guy. If I can. Yeah. And then ohm meter, we got to switch our leads on the Varus. And then digital multimeter. And let's calibrate this real quick. Just touching my leads together and hitting yes. There you go, 0 ohms. All right, so let's see what we got on this sensor. Just curious. Not the right leads for this. I don't know that you can measure these, to be honest with you. And it's bouncing. Because it's a digital signal. They got like transistors and stuff in these things, so resistance measurements resistance is futile. Yeah, like at one point I had 40 ohms, and then at another point, like yeah, I just switched my polarity now. I'm not sure that it matters. Try it. That's like a half 500,000 ohms. I had like 40,000 at one point. Yeah, I just don't know that we can do these like that. That's not a consistent resistance measurement. Okay, let's go to the other side. I guess I could start with the resistance measurement. You saw we had at least some type of continuity. It changed a whole bunch. Did that just break? It did. The clip for this connector. So are we not making contact is our problem right here. Well, nice being you're going to need a connector. Like this red clip, when I tried to pop it, it just snapped the release part of it. Was that ever making contact? I think it was. Let's do resistance here just to see if we have anything. My suspicions are we're not. And my suspicions were wrong. I can't do resistance measurements on this style of sensor. I just can't. And that could be actually, that's just me touching the housing together, the pin and this, which I can't do that. Not on a mega ohm scale. That's completely open, which is exactly what our voltage readings told us. Some of that resistance measurements on the other side, I was touching it too. We could maybe revisit that. I don't think it's necessary. I don't think the resistance measurement is how I would go about these. It would definitely be voltmeter checks or the lab scope. Okay, voltage on the scope. There's your 12 volt wire, 11.3. And then this is the one that told me, I thought initially that I didn't have a bad ground. You heard me talking about, oh, I wish I'd grab my power probe. And that voltage right there, see it's negative 0.14. And then on this design, when it's like that, when you have an open, which I believe we do, you see we have a lot of noise still in that signal. And then when I shake my lead, you see how much voltage changes? That's because it's open. It's essentially me having this lead not going anywhere and doing the same thing, right? So when you see that, it's a tip on a multimeter, a tip on a lab scope, or really for any type of voltage measurements. When you see voltage like that that's floating on you, that means you have an open. And we've already confirmed that. This sensor is open. All right, this is my signal wire. Right here, it should be coming out in that direction from the hub. I got nothing. So one final thing that we can do, in this case, because it's such a low volt signal, I would prefer to use an LED test light for this. Pete, do you have an LED test light by any chance? You just have the regular test light? Yeah. So I hate to hit it with 12 volts. I'd rather use the LED to drop the voltage down. What I was going to do is inject a signal on this and make the computer see it, just to confirm wiring's good from this location all the way up to the module. The bulb is much higher resistance, and then when I touch it on there, it won't overload that circuit. In the prototype of my SD test light, one of the things I wanted to change was the tip. I didn't like the tip. But with this light, one of the things that we were doing is we were given the option to change the bulb, right, to an LED bulb.
Are these available yet?
No, but I told Carlos we need to bring them back. Yeah. So I have an LED bulb that I'm now going to use instead of my incandescent bulb with using the same test light. So if this isn't a commercial for tools today, I don't know what is. The SD test light, still not available. Okay, so I'm going to use this LED light between the battery feed wire and the signal. And then we'll watch also the signal on the scope and see if we can trigger anything. And I don't know that this light will light. There we go. You see our signal on the lab scope? And then what we want to do is look at the front right. So I'm going between here and here. And there you go. I'm basically triggering the circuit. I just brought this sensor back to life. Did you see it work in there? Look at my voltage now. It's at 0.7. That's weird. I hope I didn't hurt anything. Did you see it work there for a second? Oh, it came unplugged. So that 0.7 is a bias. That's sweet on the signal coming down to the sensor. Sensor plugged in. Or no, it's not. Uh-oh. I didn't have that before. That might be a protection circuit in the module. It didn't like what I was doing. So let me cycle the key. Good thing I use my LED bulb. Got to be careful with this kind of stuff. Key off and wait 5 seconds. So if that was the case, let me see what happened here first. Make sure I didn't hurt anything. Yeah, look, my voltage is gone. Want to do it again? I do, especially because it now is functioning again. I guess you really don't need it plugged in for this. We've already confirmed that this is open, so this is of no significance really. That was not a bias. That was the computer basically being like, whoa, don't like what I'm seeing here. And then it was some kind of a default value that we're looking at. I'm not endorsing this, but mainly because we didn't need to. This is a signal that's being generated from this with a 12 volt feed and sends the signal this way. And so if I don't have a signal right here, then I'm not worried about an open upstream of it. This is just to confirm from here all the way to the module. So again, watching scan tool, watching scope, you can see the signal that's on that. There you go. On off, got a mile per hour signal. Yeah, so it was okay with it that time, maybe because I just did quick taps. But if I held it there, it kind of defaulted and then it definitely didn't like it. We should do it again. I don't want to hold it, but I'm going to do the rapid ones again. It's not minding it this time. I wonder what happened the first time. You see my signals aren't that high. I'm only going up to like 2 volts. So it's only slightly higher than what the sensor does. All right, cool. So, hey, Pete, is he in here?
He's outside.
He needs a hub. We need a new bearing. Junk parts, man. You might be thinking, well, what about the harness down in here behind the wheel? Sure, that could have an issue, and I didn't even look at it. Why? Because it's all one assembly. I mean, if it came as one assembly, right?
One, right?
Yeah, just change the whole thing. Right. Yeah, warranty it. But I hope you guys liked that one. That was a digital wheel speed sensor. If you got more questions on that, I have a few other videos I've done these on. Some of it within a classroom setting, so you can learn a little bit more. I'll link those in here. Yeah, let's bug Carlos at AES Wave to get the SD test light up. That's pretty cool. I can switch it, make it an LED or an incandescent. And then, yeah, definitely thumbs up on the the Top Scan Pro is going to be my new recommend when people want to know what scan tool should I buy, like a DIYer, someone like my son who doesn't do this for a living but wants a decent scan tool to interrogate the car, the system. Yeah, definitely going to be that guy. Pete, you need to get yourself one of these too. So guys, I hope you like that. We will see you next time.